Calculation of two-put parameters can be solved by two methods. One is old method, second is new method. Old method I name it because that has been followed for many days, many years. Let's see the old method. The first one will define the parameters. Then out of those two parameters, you have the variables. Put one variable as 0, get the other two parameters. Put another variable as 0, another parameters. That's why keeping 1, 0, solving two parameters. Like that you can always calculate the parameters, but this is very slow. Why it is slow? For every time, for each two parameters, we have to draw the circuit again and again. That's why it is slow, but it guarantees the solution always. That's why old method is good for when the circuit is big and when they are asking only for one or two variables. Suppose if they are asking more than one parameter, it's better to go by new method. The new method I mean like that. If you go for the new method, what I have suggested is count the number of loops you have, count the number of nodes you have. If the number of loops are less, go for mesh analysis. If the number of nodes are less, go for nodal analysis. In the process, you will get two equations. Adjust those two equations into the parameters you wanted. That's the best thing, suitable, and it's very fast solution if the number of nodes are less. So I am going to take some problems, and the first thing that you should observe me is which method I am taking. Am I taking the new method or old method? That's the first thing. Second is how am I adjusting this circuit so that the answer will come very fast. So let us take some previous question paper problems or some other problems which we have formulated or taken from some books, but ultimately to give you the best concept and the full concept that we have for exam. Let's go to problems now. Problem 1, question number 1. If you look at this, the question I am reading, calculate y and z parameters of the network shown in figure if exists. That means there is a doubt it may exist or may not exist. I am slowly developing the concept by taking one called, I am taking a serial branch, then I am going to a shunt branch, and then I am going to take a L shape, T shape, pi shape. These are the minimum varieties that you need to learn. Then I will go for a bridge T, then varieties like a lattice network. So first let us see some standard problems which one have to understand so that he can develop any other problems based on this. So this problem goes like this. The first thing that it says is he has taken only one branch. Look at this circuit. He gave Z here, V1, V2. Okay. This is I1, I2. Now what will happen? For example, the first thing that you should know is how many loops are there, how many nodes are there. This is only a single loop, and best thing you can do is obtain KCL. KCL at V1 minus I1, V1 minus V2 by Z is equal to 0. So I1 is 1 by Z into V1 minus 1 by Z into V2. This is our first equation. Then go to KCL at V2. At second, what is the KCL there? Means here minus I2, V2 minus V1 by Z is equal to 0. So I2 is 1 minus Z V1, 1 by Z V2. Call this as second equation. So when you call this as second equation, and what is our parameters if you identify? These are I means y11, y12. So directly from here you can say y11 is equal to 1 by z, y12 this is 1 2 minus 1 by z. From the second equation you can say y21 is minus 1 by z, y22 is 1 by z. These are the equations you have, these are the parameters. One way the answer for z parameters or y parameters is over. Suppose if I call this as y matrix 1 by z minus 1 by z minus 1 by z 1 by z, this is a parameter. If you want z parameters, the best answer is y inverse. Z parameters is generally inverse of y. Now if you want to have inverse of y, we need delta y. What is delta y here? 1 by z whole square minus 1 by z whole square. That means 0. Then this will become infinity. Therefore, z parameters do not exist. So, for this solution, z parameters do not exist, but you have y parameters as the answer. That's the solution for the problem 1 or the question 1. Question number 2. Calculate z and y parameters for the network shown in figure if exists. This circuit is Y. The name of the circuit is shunt branch. This is Y. Now what I will do is KVL to loop 1 plus V1 1 by Y I1 plus I2 0 Y. This is a loop. In this you have two currents I1 I2. So 1 by Y I1 plus 1 by Y I2, first equation. By that you can say Z11 is 1 by Y, Z12 is also 1 by Y. Now let me take the second equation. KVL to V2 plus V2 minus 1 by Y I2 plus I1 is 0. That means V2 is 1 by Y I1, 1 by Y I2. So this is Z21 1 by Y, Z22 1 by Y. Therefore, Z matrix is 1 by Y, 1 by Y, 1 by Y, 1 by Y. That's the first answer he wanted. Then if I go for Y matrix is Z inverse. That depends on delta Z. What is the delta of this? 1 by Y square minus 1 by Y square is equal to 0. Therefore, it doesn't exist. So, Z parameters exist, Y parameters do not exist. That's the solution for this problem. Question number 3. Calculate Y and Z parameters for the network shown in figure. We are not creating any doubt here, exists. As I told you, I am adding this serial branch, parallel branch. By adding the serial branch and parallel branch, the network becomes L network. That's called L-shaped network. So I am taking L shape. This is V1 here, V2 here, ZA, ZB, I1, I2. Okay. Now what I am going to say, solution KVL to V1. When I say KVL to V1, V1 is equal to ZA I1, ZB I1 plus I2. Okay. By that you can say ZA plus ZB into I1 plus ZB into I2. Therefore, Z11 is ZA plus ZB, Z12 is ZB. Then KVL to V2. V2 minus ZB into I2 plus I1. Please remember, this is current is I1, this current is I2. If both currents are added, that is what here is equal to ZB I1, ZB I2. So Z21 is ZB, Z22 is ZB. Therefore, Z matrix is ZA, ZB, 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 ZB. That's the Z matrix we have. And if you go for Y inverse, what will happen is Z inverse. So calculate the inverse matrix. Okay. And if you calculate the inverse matrix, what happens is that is nothing but 1 by delta Z. ZB comes here, ZA, ZB comes here. Minus ZB, minus ZB. With that, you can have your answers. So that is, in this problem, you have both Z parameters as well as Y parameter. Here, delta Z is equal to, if you calculate, ZA, ZB. In the process, Y11, Y12, Y21, Y22. This is nothing but here ZB, ZB cancel, ZB by ZA, ZB, so 1 by ZA. Like that, here you can say minus minus become, this is plus here, this is minus, that will have 1 by ZA. So same values there, only difference is with the minus sign. Second one, what will happen, again ZB cancel, so this is minus 1A ZA, because both are same. The last one has a bigger thing, ZA plus ZB by ZA, ZB. That's going to be your answers. So that's how you can convert the parameters. So calculate the parameters, convert the parameters. This method, I call it as new method, which I have introduced first time, so that students can enjoy this procedure just like KVL and KCL. Okay. Question number 4. Calculate Y and Z parameters for the network shown in figure. I took T network. This is the network you have. ZA, say ZB, ZC. This is I1. Okay. Now what will happen is, this is called unsymmetrical. T network. Why it is called unsymmetrical? Because these two are not equal. Now let us go to solution. Plus V1 minus ZA I1, ZC I1 plus I2, 0. So ZA plus ZC into I1, ZC into I2. Therefore, Z11 is ZA plus ZC, Z1 is Z2. Straight away the answers will come if you use new method. If you use old method, it is a very time taking. This is called KVL to I1. Actually, if I see the number of loops here, number of loops is 2. Number of nodes is equal to 3. 1, 2, 3. That's why I am not going to nodes, I am going to loops. This is KVL, this is KCL. If the number of nodes increase more than 3 or more than 2, don't go for it. Always go for the lesser one. Loops are less, go to KVL. Loops are nodes are less, go to KCL. Even if he is asking Y parameters, go to Z parameters and then convert. That will take same time. Then I am taking you to KVL to V2. V2 minus ZB I2. I2 plus I1 is equal to 0. ZC I1, ZA ZB I2. Therefore, Z21 is ZC, Z22 is ZA plus ZB. So, Z matrix is, look at here, ZA plus ZC. This is ZC plus ZB, ZC, here also ZC. That's the Z matrix. If you want Y matrix, what is the answer? Inverse. Inverse means what? 1 by delta Z, Z22 Z11 minus Z12 minus Z21. That way you can adjust these values. So I will always give you one of the parameters, you can adjust into other parameters. Like in the previous classes, what you studied, how to convert or how to adjust, I already taught that method. So minimum I will give you one parameter, conversion you do. This is what I mean by this problem. Question number 5. Calculate Y and Z parameters for the network shown. Let us see the network. The network is like this. What do we call this network? We call it as pi network. Pi. It's a pi network here. So call it as ZA, ZB, ZC. This is also I call unsymmetrical pi network. What is that actually? Say this is V1, V2. This is I1, I2. I1, I2. So what happens here? Suppose solution. Number of loops, how many? Number of nodes are how many? If number of loops are taken 1, 2, 3, number of nodes are only, so by that, which one shall we take? Nodes is better. Nodes means what? KCL. Loops means? Yeah. So I am going to take KCL at V1 minus I1 plus V1 by ZB plus V1 minus V2 by ZA 0. So I1 is 1 by ZA V1 plus not only that, not only V1, you also have 1 by ZB into V1 minus 1 by ZA into V2. This is first equation. If I go for second equation, KCL at V2, okay. Now if I say minus I2 here, V2 minus V1 by ZA plus V2 by ZC 0. I2 is 1 by ZA into V1 1 by ZA 1 by ZC into V2. Therefore, if you identify the Y matrix, this is YA plus YC, YB here, this is minus YA. Because when you say 1 by ZA, I can call it as YA. Here minus YA, YA plus YC. So once you get Y matrix, you can always get what you call Y inverse. So first you get Z, Y, and then come to Z. So for each circuit, I will show you either to calculate Z or Y. Once you get one, other things anyway you can directly go. If it is within the parameters, you go inverse. If it is outside parameters, you adjust equations. So that is our equation concept for pi network. Question number 6. Calculate Z and Y parameters for the network shown. This is taken with dependent source. That's very interesting. So for example, this is a circuit. This is another resistor there. Like this, for example. This is plus minus 2V1 and the arrow shows towards upwards 3V2, or that is, this is 2, this is 1. Suppose, and call this as R1, R2, R3. This is the circuit. I1, I2. Okay, right. Now, though the circuit seems to be heavy, don't worry. I am still going with new method. In that, as you know, number of loops. How many? Number of nodes, how many? 1, 2, 3, 4. Oh, very much. 1, 2, 3, 4. Nodes, one here, one here, only 2. Though the circuit seems to be difficult, but this is very bad. Go here. That means we are going with KCL. So I am going to apply. Therefore, we are going to take KCL at V1 and V2. From there, you will get Y parameters. After getting Y parameters, you will say Z parameters is nothing but Y inverse. That's the meaning. So let me take it. The first one is KCL at V1. If I apply KCL here, minus I1, V1 by R1, V1 minus 2V2 by minus this by R2 plus, that's all, is equal to 0. So you can convert it as something into V1 something into V2. This whatever you have here is called admittance. Y11, Y22. Similarly, if you go to KCL at V2, minus I2 plus V2 by R3, V2 minus of minus 2V1 by R2 minus V1. Another thing is also here, minus 3V1 is equal to 0. So adjust this, something into V1, something into V2. This will be Y21, Y22. So at the end you are going to say Y matrix is consisting of Y11, Y12, Y21, Y22. Therefore, Z matrix is Y inverse. So calculate this one, and from there calculate this. So though the problem seems to be very complicated, the main things examiner are interested in this equation and this equation. If these two equations are correct, total is correct. The rest of is only a simplification which you can do by yourself. Calculate H21 for the network shown, GATE 1999, 1 mark EC. Let me see what is this circuit here. The circuit is basically a T network. He gave all the values as equal, V1 and V2 here. He is asking H21 solution. Okay. When you go to the solution, you have two options. Because he is asking H21, I will take a direct approach. What is direct approach? First, right, old method I am taking. As I told you, I will demonstrate both the methods for the convenience of a student. In a old method, when you say, first step is write the equation V1 H11 H11 I1 H12 V2. I2 is H21 I1 H22 V2. What the best I am going to do for you? Because he is asking only one parameter, we need not waste all the parameters and calculate. So what I best say is, you want H21, then what to do? Put V2 0. Put V2 0 in the circuit. Then calculate I2 by I1. How much? That is actually called H21. Suppose if I say V2 0, this is called V2 0. V2 means voltage, voltage means short circuit. Now this is I1, this is I2. Now it is like a current divider rule. So I2 is equal to minus I1 by total car resistance into opposite. So I2 by I1 is equal to minus R by 2R minus half. That's why the answer is A. Our option is A option. What a simple way that I can calculate. This you can as well calculate from Z parameters and then convert into H parameters. But in this problem, old method is better because he is asking H parameter. You don't need to go to Z and then come here. Secondly, he is asking only one parameter. Better go by old method. That's the goodness of old method sometimes. Question number 8. Then question is calculate Y12 admittance. GATE 2001 1 mark. Please understand, when is given 1 mark you can't waste much time. ABCD are also given. Look at this. This is the question he gave. 20 ohms, 5 ohms, 10 ohms. As usual, V1, I1, I2, V2. He is asking for, this is a circuit given, he is asking for Y21. This is given in GATE 2001, 1 mark is C, and the options are given there. You can see. Now, there are two ways. Shall I go with the old method or new method? Generally, old method is good if one is asked, but this being, here we are going to go for KCL because loops are 3, nodes are 2. So KCL will anyway give Y parameters. So Y parameters are directly coming. Therefore, though he is asking for one parameter, I am going for new. Let me go. Moreover, only this one requires KCL. KCL at V2 minus I2, V2 by 10, V2 minus V1 by 20 is equal to 0. So 1 by 20 with minus sign, 1 by 10 plus 1 by 20, V2, V1. So this is V21, this is Y22. So Y21 is minus 1 by 20 minus 0.0 mhos. That's the answer, and option is C there. Option is C. Question number 9. Calculate Z11, Z21 for this is the circuit. I1 2 ohms, 4 ohms, 10 V1, V2. Let me start. KVL to V1. V1 minus 2I1 minus 4I1 plus I2 plus 10 V1 0. 11 V1 2 plus 6 I1 4 I2. 6 by 11 I1 4 by 11 I2. Therefore, Z11 is 6 by 11. Z12 is 4 by. Now once again you see options. But very unfortunately, 6 by 11 has come, but it is there in all ABC. I thought of escaping. But at least from here, I can say option is either A or B, because 6 by 11 is there. Now I need to eliminate this another option from V2. For that, I will do KVL to V2. V2 minus 4 into I2 plus I1 plus 10 into V1 0. So 4 I1, 4 I2 minus 10 into what is V1? 6 by 11 I1 plus 4 by 11 I2. Now what you do is take common. 60 by 4 I1 plus something into I2. We are not interested. 44 minus 60. When you say 44 minus 60, it will become minus 16 by 11 I1. So this is something into I2. This is Z21. This is Z22. This is not our interest. Our interest is here, minus 16 by 11. Therefore, our option is A. That's how you need to solve. Question number 10. Calculate Z11 and Z12. This is a problem like this. Suppose you take this as 2 ohms, they have given us 2 ohms, 2 ohms, 1 ohm, 1 ohm. And this was given in GATE 2001, 1 mark. It is very terrible to understand. If you go with my new method, solution, how many loops are there? 1, 2, 3. How many nodes are there? 1, 2, 3, 4 above. My God, it's too much then. Then the best thing you can go with this loop also bad. Both are bad. You cannot waste your time like that. Even if you want to go with the old method, also it is bad, because if you say V10, V20, it's a laborious thing. Because Z11 says V1 by I1, I20. Z12 says V2 by I2, I10. That is V1. By that, what you are understanding? Once you are making I10, I20 means 2 times you are wasting your time. This is time waste. This is also time waste. At times, both my methods, the old method of the old everybody and the new method I started, both fails. Then the next option I want to take is star to delta transfer. Let me go for star delta. The best thing is that you can have a star delta here. What is the star delta for your possibility? The star delta is, if you want anything, say for example this is R1, R2, R3. R1 is 1 into 2 by 1 plus 2 plus, so 2 by 4. R2 is also 1 into 2 by 1 plus 2 plus 1, 2 by 4. R3 is 1 into 1 by 1 plus 2 plus 1, 1 by 4. Now if I redraw the circuit, I have a circuit like this. So this is 1 by 4, this is 2, 2 by 4, 2 by 4 and 2. Now what happened? This became an ordinary circuit, simply converted into. This is, therefore 2 by 4 is this, total becomes 2.5. This becomes 2.5. This becomes 0.25. Now if you really go for your ordinary style, because you want impedances, then go for KVL to I1. V1 minus 2.5 I1 plus 0.25 I1 plus I2, 0 or minus. So V1 is equal to 0.25 and 0.5, 2.5, 2.75 into I1 and something into I2, because you are interested in Z11 here is 2.75 is the answer there. But if you look at the options now, sometimes you can make out, let us see the options there. 2.75 is there in only one and he is out now. My option directly I'll put A without solving the next one, because he has done a mistake. Maybe he wanted us to check us. So always enjoy this style of writing. When he's asking for 2, you get the 1 and say if 1 is sufficient to make this conclusion, finish it off. Don't need to go for second. But anyway, for your sake, I'll do that. Let me do for the student's sake. To find out the second one, for that I will go for KVL to I2. When I go for KVL to I2, then I have this one here, V2 minus 2.5 I2 minus 0.25 I2 plus I1. Therefore, V2 is equal to 2.5 I1 plus 2.57 into this. This is Z 21. This is Z 22. But anyway, he is only interested in what answer? He is interested only here also. Z12. Can I do that? If I come here, it is 0.25. Now please check your answers there. Very interestingly, that is also there, Z12 0.25. So in that case, this is not required. You can just manage with one equation. What a fast thing it is. That's why the method I am proposing has become the best of all. Enjoy this method. And in only certain cases, worst case where my first method, the new method I started fails, go to old method. Even that is also, as on so far today, I never used any old method. Except in one case I tried, that also you can manage with new method. So that's how there are two methods to solve the problems. Go with one of those two methods. First preference is new method, worst case old method.